So, the first chapter, or the first part I'm going to cover in this video, is scalar functions. And essentially there are four basic things you need to know. The first one are level curves. The idea that you take a function, I've written a sample over here, you take a function and you set all of it equal to some constant k. So, we get k equals x squared plus y squared. Now, pick different values for k in the range of this function, which I'll discuss in a minute. Pick different values for k and start graphing them on an xy grid. Let's say you pick k equals 0. That's x squared plus y squared equals 0 is just a point at the origin. Let's say you pick k equals 1. X squared plus y squared equals 1 is a circle about the origin of radius 1. Graph that and keep doing that, and that's the idea of level curves. Next is cross sections, which is the idea that you take one of the two variables, either x or y, one at a time, and you set them to a constant. Just treat them like an arbitrary constant, not a variable. So let's say z, which is f of xy, equals, I hold x as a constant. Let's call it c plus y squared. This is a function, two variables now because x is a constant, and you graph this in the yz plane. As you can clearly see, this will be parabolas, and depending on the value of c, the parabolas will either be shifted up or down. Similarly, you do the same thing except with y this time. Before, I set x as a constant. Now, set y as a constant. And let's call this constant d, let y squared equals d. Again, you plot this in the xz plane. And again, this is a parabola opening upwards, and it can be shifted up or down depending on the value of d. So, those are the cross sections. The third one is domain and range. This will probably show up on a midterm, though I don't think it will be worth a lot. I haven't seen the midterm. So the domain of this function is really simple, or you basically have to infer from the question. Over here, you can pick x and y as any numbers that you want, any real numbers. So there's basically no restriction. So x and y, and excuse my handwriting, is an element of R2. R2, not R, because there's two variables, and you pick them in pairs. Similarly, the range can be any real number that we want, because there's x and y can be any number, and so z can be any number. So we write z as an element of R. However, x squared is always positive, y squared is always positive. So x squared plus y squared is always going to be positive, so z is greater than or equal to 0. So we have domain and range. And the fourth part is something that I can't really demonstrate over here, but it's very, very important to know as well. Using level curves and cross sections to sort of create a three-dimensional picture, and usually you'll have to draw out all three axes and sort of use the cross sections, level curves, and it can be a bit tricky to sort of visualize in your head what the picture looks like, but it's very important for this midterm. So the next part of the video is going to be limits, which is probably one of the most important concepts for this midterm. So you are likely going to be encountered with a question that says, find the limit as xy approaches a number of a function. And I've just made up this function as an example. So the very, very first thing you need to do is check for continuity theorems, which is essentially means, can you sub in the numbers directly into the function and get a value? So let's say you are approaching the value of 1, 2 for this function. You can basically sub in the numbers perfectly into this, and you'll get 2 over 5. Perfect. So all you have to do in that situation, if you don't get any problems with just substitution, state that by continuity theorems, this limit exists and is equal to 2 over 5 in this case. Most of the times it won't be like that, in which case you need to start trying different paths to approach along. The most sort of common paths you should definitely try are x equals 0, y equals 0, y equals x, or y equals mx. And there are different other paths you have to choose. Just make sure that the point you're approaching, let's say it's 0, 0, just make sure the point that you're approaching is actually on the path that you're trying to check. So you try different paths and you keep trying it to see what limit you get. Now, one of two things can happen here, as you can see in this tree diagram I've drawn. You try two different paths, and let's say you get two different limits. That immediately means the limit does not exist, state that you're done. On the other hand, another thing that can happen is that, let's say you approach along a line, let's say y equals mx, and all the x's cancelled, and you're left with something like 1 plus m over 1 minus m. Since we can change the value of m, the limits are going to be different for different values of m. The limit does not exist, which is the second thing I've written here. However, On the other hand, if you start plugging in paths and you keep getting the same limit over and over again, and you have a feeling that it actually does exist and is equal to what you're finding again and again, you use this inequality, which is squeeze theorem. Basically, let's say you approach along different paths and you keep getting that the limit is 0, which is probably the case over here. So you pick f of x, which is the thing, minus what you think is the limit. Just assume it is 0. You state the limit, and you find an inequality. You find a function b of xy, which will require some manipulation, and find a function b of xy, which is smaller than f of x minus L. Find its limit, and if it is 0, the limit exists, and it is what you assumed it to be. So that is essentially what you need to know about limits. So the next part of this video, I'm going to be discussing continuity. Basically, is a function continuous at a point? Essentially, questions will probably look like this. Is f of xy equals this function continuous at 0, 0, or at any point a, b? This is just an example that I've written over here. The very first thing you need to do for questions like these is take the limit. And I've shown you how to do that in the previous section of this video. So you start taking the limit. So limit as x or y approaches this value of a, b, 0, 0, and you take the limit. Let's say you take the limit and you see that it does not exist. Immediately, the function is not continuous, you know that. On the other hand, let's say it does exist. Now, two things can happen. The first thing is, it exists. So let's say we found that it's 7. So the limit is 7. But this function is not continuous. Why? Because in order for a function to be continuous, the limit has to be equal to f of ab, where ab is the value that you're approaching. So we're approaching 0, 0, and f of ab is actually 0. So if f of ab is 0, and if we find the limit to be, let's say, 7, it's not continuous. On the other hand, let's say we find the limit is actually 0 for this function. Since the limit is 0, and f of ab, which is f of 0, 0, is 0, we know that it is continuous. Simple. So basically it's using the limit idea and checking to see if it equals f of ab for the point that you are approaching.